Analysis with RevMan for Cochrane DTA reviews. There are a number of steps involved in developing a Cochrane DTA review. This lesson, within the Analyze and Present Results module, describes how to use RevMan to create the three main types of analysis that may be performed in a Cochrane DTA review. The objective of this lesson is to understand how to use RevMan to create different types of analysis for a Cochrane DTA review. Methods for undertaking the analysis are beyond the scope of this lesson. Other lessons in this module address the theory and practical application of the methods recommended for test accuracy meta-analysis. Additional details can be found in the Analyzing and Presenting Results chapter of the Cochrane DTA Handbook. I will demonstrate how to create an analysis of a single index test, including investigation of heterogeneity for a single index test. I will also demonstrate how to create an analysis comparing the accuracy of two or more index tests, as well as investigation of heterogeneity for such analysis. The three main types of analysis that can be done are based on the types of questions that can be considered in a Cochrane DTA review. What is the diagnostic accuracy of a particular test? How does the accuracy of two or more tests compare? How does test accuracy vary with clinical and methodological characteristics? The example I'm using is a Cochrane review of rapid diagnostic tests for detecting clinical P-falciparum malaria. The main objective of this review was to assess the accuracy of multiple tests in order to identify the best performing test. This example will be used to illustrate the three main types of analysis. RevMan requires separate steps for organizing data entry and specifying analyses for DTA reviews, unlike the combined approach it uses for Cochrane reviews of interventions. Therefore, an appropriate data structure and a clear analysis plan is essential. To add an analysis in RevMan, right-click on Analysis to start the new Analysis wizard. Type the name of the analysis, here type 1. The next page of the wizard shows the different types of analysis. Select the type of analysis, in this case a single test analysis, and next select the index test to be analyzed, in this case type 1. Finish creating the analysis. The wizard only enables basic creation of the analysis. To modify the analysis and plots, such as summary ROC plots and forest plots, you will need to edit the properties of the analysis. A single test analysis has been created for type 1 RDTs. The analysis pane shows the forest plot and summary ROC plot. Next to the plots is a section for entering parameter estimates from external analysis. Methods that jointly analyze sensitivity and specificity and also take into account heterogeneity in test accuracy are recommended for meta-analysis. The two methods commonly used are the bivariate and hierarchical summary ROC models. The theoretical basis of these models is explained in another lesson within the Analyze and Present Results module. Hierarchical or mixed models cannot be fitted in RevMan. Exploratory analysis can be undertaken in RevMan, but formal analysis will need to be done in software packages such as SAS, Stata, S+, R, MLWin or WinBugs or OpenBugs. Given the complexity of fitting the models, the review team should ideally include someone with the necessary statistical expertise. Right-click on the analysis and select Properties to open up the Properties dialog box for analysis. On the General tab, the main properties of the analysis, such as the type of analysis and the index test, can be changed. On the Summary ROC Plot tab, the properties of the Summary ROC plot, such as scaling of study points, can be changed. Because many points in the malaria example lie along the sensitivity and specificity axis, the axis of option has been selected. This will remove the axis and the plot area will be grayed instead. This is the Summary ROC plot for the index test based on the options selected. The forest plot can be edited by changing the options on the Forest Plot tab. Covariate and quality items can be added to the plot. This is useful for presenting key data. The studies on the plot can be sorted according to covariates, quality items, sensitivity, specificity, study ID, and so on. This is useful for exploring patterns of variation in the data. This is a forest plot for the 65 studies of type 1 RDTs. The continent covariate is shown on the plot. The studies are ordered according to continent, sensitivity, and study ID. Potential sources of heterogeneity that will be investigated should be specified in the review protocol. For investigation of heterogeneity, covariates for the different factors must be created in RevMan. The covariates can be continuous or categorical. Graphical presentation of investigations of heterogeneity on forest plots and Summary ROC plots can only be done using categorical covariates. Formal investigation of the relationship between a categorical or continuous covariate and test accuracy is done using meta-regression models. Depending on the meta-analytic model used for the analysis, differences in parameters of Summary ROC curves or summary sensitivity and specificity points can be investigated. Covariates can be easily added in RevMan by using the new covariate wizard. Right-click on covariates to start the wizard. In the malaria review, the authors investigated heterogeneity for only type 1 tests because this was the only test category with sufficient studies for analysis. One of the factors they investigated was the continent where the study was conducted. Studies were conducted in Africa, Asia, and South America. Covariates can be added at study level or test level. For example, age group and continent are study level covariates because the covariates apply to the entire study and not to a single test or subset of tests evaluated in the study. On the contrary, a test level covariate applies to a specific test. For example, a threshold covariate that defines the different thresholds reported for the test. This covariate will not apply to other tests evaluated in the study. The continent covariate is a categorical covariate. Each subgroup of the covariate is added. In addition, a blank subgroup is created and used as a default value. Creating a blank subgroup is not essential. It's simply a way of avoiding data entry errors by ensuring that the field is blank for all studies to begin with. Here are all the covariates that were created in the malaria review. A new analysis can now be added to investigate the effect of continent on the accuracy of type 1 RDTs. Unlike in the previous analysis, this time the investigate sources of heterogeneity box is ticked. The creation of the analysis is complete. The analysis looks the same as before because a covariate is yet to be selected for the analysis. The properties of the analysis need to be edited. A categorical covariate or quality item from the Quadus or Quadus 2 assessment can be selected for the analysis. For this analysis, the covariate continent is to be investigated. continent has three subgroups: Africa, Asia, and South America. It is possible to select certain subgroups because an analysis may require only some of the subgroups. For example, only 2 studies were done in South America, while 39 were done in Africa and 24 in Asia. Therefore, the investigation can be restricted to just Africa and Asia, especially the meta-regression analysis, because of limited data for South America. This is the analysis of a single test with investigation of heterogeneity. The black circles represent studies of type 1 RDTs in Africa, the red diamonds represent those in Asia, and the green squares represent those in South America. This summary ROC plot shows the analysis of a single index test without a covariate, while the second plot shows the investigation of heterogeneity using continent as a covariate. The analytical strategy used in this review was to compare the diagnostic accuracy of commercial brands within each test type before making comparisons between test types and then between antibodies. First, the comparative analysis included all studies with relevant data, and then the analyses were restricted to only studies that made direct comparisons between tests using the same study population. For this analysis, all studies of type 1 and type 4 RDTs will be included. This is an indirect test comparison. Multiple test analysis is selected and the 2 index tests to be analyzed are selected. This is the analysis comparing type 1 and type 4 RDTs. There are 65 type 1 studies and 16 type 4 studies in the analysis. Some of the studies compare type 1 and type 4 in the same patients. To restrict the test comparison to comparative studies of the 2 RDT types, another analysis must be created. This time, in addition to selecting multiple test analyses and selecting the 2 tests, the Analyze Paired Data Only box is ticked. This is the paired data analysis. There were only 7 comparative studies of type 1 and type 4 RDTs. Each dotted line connects the pair of points representing the 2 tests in each study. Investigations of heterogeneity can also be done for analysis of multiple tests. However, this is not often analyzed using meta-regression because of limited data. The Investigate Sources of Heterogeneity box is ticked for a multiple test analysis. For this analysis, the effect of the continent covariate will be investigated again. Select continent to investigate the effect on the relative accuracy of type 1 and type 4 RDTs. This is the analysis of a multiple test with investigation of heterogeneity. The data corresponding to different tests and continents are represented using different symbols and colors. This plot is not visually appealing because there are lots of studies and the studies are generally clustered together, making it difficult to observe any pattern of variation. The value of presenting such a plot may be limited. Edit the properties of the summary ROC plot. For example, remove the summary ROC curves and adjust the size of the study points. Here is the complete summary ROC plot showing the 2 test types and the continents where they were evaluated. This summary ROC plot shows the analysis of multiple index tests without a covariate. The second plot shows the investigation of heterogeneity using continent as a covariate. To summarize, RevMan can be used to create the 3 main types of analysis that are possible in a Cochrane DTA review. A Cochrane DTA review will include at least an analysis of a single test or analysis of multiple tests, even if meta-analysis is not possible. Investigations of heterogeneity are always planned, but not often done because of poor reporting of potential covariates and/or limited number of studies. RevMan is needed for the analysis as well as statistical software if meta-analysis can be performed. See other lessons in this module for additional information. The lesson on the theoretical basis of Cochrane DTA meta-analytic methods will introduce hierarchical models for meta-analysis. The lesson on estimating summary ROC curves and average operating points will show how the models can be fitted in SAS and Stata and how to obtain the output that you need to transfer into RevMan to produce summary ROC plots with HSROC curves or average operating points with confidence and/or prediction regions.